Class 6C Physics Chapter 6 Magnetism Part 1 we have discussed earlier. Today we will be discussing Part 2. From question number 16. How will you make a bar of iron and electromagnet? Draw a diagram showing the polarities of an electromagnet. At first we will take a iron bar AB and will wound several turns of insulated copper wire over the bar. Connected the ends of the wire to a battery through a switch and press the switch to pass current. After some time, the bar AB becomes a magnet. The end A of the bar at which the current enters the coil in clockwise direction becomes the south pole and the end B of the bar becomes the north pole. Diagram is given in figure 6.15, page number 85. Number 17. State two ways of increasing the strength of an electromagnet. Two ways of increasing the strength of an electromagnet are by increasing the current in the coil and by increasing the total number of turns of the coil. Number 18. Suppose you are given a long bar magnet and you are asked to break it into four small magnets. Draw diagrams showing the polarities of each broken part. Diagram is given in page number 81, figure 6.6c. Number 19. State three important uses of a magnet. Three important uses of a magnet are as follows. Magnets are used in electric motors, speaker, etc. Magnetic compass is used to find the geographic direction at a place by sailors. Strong electromagnets are used for loading and unloading scraps of iron. Number 20. What is magnetic induction? Explained with the help of diagram. Magnetic induction is a process in which a piece of iron temporarily behaves like a magnet in the presence of another magnet. We will take a long nail and put it on the arm of a stand passing through a cork. Spread some iron pins on the base of the stand. We will notice that the pins do not move towards the nail. Now, on touching a magnet at the end of the nail, some pins clings to the nail. It happens because the nail turns into magnet and acquires the properties of magnetism, and on removing the magnet, the pins fall down. Diagram is in page number 83 and 84. Number 21. In which direction does a suspended bar magnet come to rest? Give reason. A suspended bar magnet comes to rest in north-south direction because of the magnetic field of the earth. Number 22. State three differences between temporary and permanent magnets. Temporary and permanent magnets, it is made up of soft iron, and permanent magnet, it is made of steel. Temporary magnet, its magnetic strength can be changed. Permanent magnets, its magnetic strength cannot be changed. Temporary magnet, it is still demagnetized. Permanent magnet, it is not easily demagnetized. Number 23. State three ways of demagnetizing a magnet. Three ways of demagnetizing a magnet are as follows. By rough handling, by hammering the magnet repeatedly, by heating the magnet to a high temperature. Number 24. Suggest one way to recognize the magnetic field of the earth. If we suspend a magnet such that it is free to swing, we see that it always rests in the north-south direction. The north pole of the magnet lies in the geographic north direction and the south pole of the magnet lies in the geographic south direction. Therefore, there must be the magnetic south pole of the earth in the geographic north and the magnetic north pole of the earth in the geographic south. 25. Name the material of core of an electromagnet for a temporary magnet and a permanent magnet. Temporary magnets are made of soft iron. Permanent magnets are made of iron, steel, cobalt, etc. Number 26. You are given an iron nail, a torch cell and a long piece of insulated copper wire. With the help of a labeled neat diagram, describe in steps how you will make the nail an electromagnet. To make an electromagnet, we will coil the insulated copper wire around the iron nail. Attached the free ends of the wire to the terminals of a dry cell through the switch. Closed the switch so that electric current flows through the copper wire. Now we will bring the iron paper pins close to the iron nail. The paper pins get attracted to the nail, showing that the nail has turned into an electromagnet. Now if we touch off the current, the iron paper nails will drop off the iron nail. Number 27. Describe an experiment to illustrate that like poles repel while unlike poles attract. We will take two bar magnets A and B. Suspended one magnet A with a silk thread so that it is free to swing. The magnet A will come to rest in the north-south direction. Now hold the other magnet B in one hand and brought its north pole near the north pole of the suspended magnet. We will observe that the two poles repel each other. Now if we bring the south pole of the magnet B near the north pole of the suspended magnet A, we will observe that the two poles attract each other. Thus, the above experiment shows that like poles repel each other while unlike poles attract each other. Number 28. What are magnetic keepers? Name its material. Magnetic keepers are used to store magnets. Magnetic keepers are small pieces of soft iron. Number 29. How are the north and the south poles of a magnet located? Explain. We will suspend a bar magnet with a silk thread from a wooden stand. The magnet swings for some time and then eventually comes to rest in a particular direction. It is north-south direction. If we disturb the magnet a little, the magnet again comes to rest in the north-south direction. The end of the magnet which points towards the north is called the north-seeking pole and marked by capital N, and the end which points towards the south is called the south-seeking pole and marked as S. Here students, we are finishing our chapter. Thank you.